first lesson, but it's a lot of vocab. So I'm just gonna kind of be showing you what's important on this slide. You do get to use your notes on tests. So, just look up the definition in your notes and then pick the best answer when you just get to your practice in your quiz. I'll put them in the basket. I'll take them out later. All right. So here's the image we're using, and we're gonna label all of these things. There's not really a good way to like draw the line the way that it's set up. So I'm just gonna write whatever the vocab word is next to the example or definition. All right, so first let's look at line segment AB. So that is right here. Out of all of these vocab words, which one best matches what line AB is? Right here. Chord, good. All right, so seeing how much you remember from the semester. So we'll talk more in depth as the slides go on, but chords basically go from one end point on the circle to another one. And it won't go through the center. That would be a different word. So as long as it doesn't go through the center, but it touches 2 points on the circle and ends there, it's a chord. All right, now we have the distance from E to B along the circle. So right here, what would that be? Good, I'm going to put arc length, because arc will fit better in one of these other definitions. So we're going to put arc length for that one, because it's the distance from E to B along the circle. All right, now next one, the outside circle and the inside circle. So outside circle and the inside circle. Concentric circles. This one I'll draw the line because I don't really have room to write it. Good. Line DB. So line segment DB. What would that one be? Diameter. All right, it's not a chord because it goes through the center all the way across. That's your diameter. So diameter is really specific. If it's not the diameter, it's a line segment going to both ends of the circle, then it's a chord. All right, now we have a line that continues. You can see by the little arrows at the top of this. So it's not a line segment. And we're talking about FG. Anyone know what that's called from this past year? We haven't covered it in here. Good, secant. All right, so that's our secant. The opposite of that would be tangent. So secant is a line that continues and it goes through the circle. All right, so it's not a line segment, it's a line that goes through the circle. What about the line EJ? Good, that one is tangent. Tangent doesn't go through the circle. It goes like, it touches like one of the outer edges of the circle, but it doesn't actually go in the circle. All right, so it would be tangent if that's the line drawn on one of the points of the circle. What about EB? With that symbol on top. Good, arc. I don't usually see that symbol drawn, but if it is, that means it's talking about an arc. So the distance around the circle would be what? Circumference, good. Kind of like your perimeter of the circle. So distance around the circle is circumference. And lastly, CE is radius. So radius goes from the center to basically any edge of the circle. It has to start at the center. And it's always half of the diameter. All right, I would use this slide as your model when you do the vocab section of your test. Questions about this? All right, some of these we're going to talk more about at length, so don't worry if you're a little confused. We might clear it up in the next few slides. And it is a lot of highlighting, so I'm just going to kind of show you the important parts. We have central angle and the arc. So arc is one piece of the circumference of a circle. So over here on the picture, if you want to highlight that, draw it, whatever. That's one piece of the circumference of the circle. That is my arc. If you connect the endpoints of an arc to the center of a circle, so how they did here, like that, they connected it to the center, you will have created a central angle. So this right here is your central angle. A central angle is an angle on the interior or inside of the circle where the vertex is at the center. Right, so if it's not at the center, it's not a central angle. Right here, you can see that it's the central angle is labeled as 80. And you know, here's just some verbiage maybe you want to be familiar with. So if I say angle ITP, or also known as angle T, intercepts arc PI. All right, that's what we need. This would intercept this arc. Angle T intercepts this arc. So just be familiar, that's what we need. Question? All right. So next page. Then we have other verbiage. So we have things like semicircles. So that would be an arc where the central angle is created by the diameter, or also known, I just always have thought of it as half a circle anyway. All right, so that's a semicircle. And the diameter is a straight line. That's why that angle is 180 degrees. All right, so straight lines have an angle of 180 degrees. So semicircles have an angle of 180 degrees, which makes sense because since semicircles, half a circle and a full circle is 360, well, half of 360 is 180. One thing you'll also notice that it doesn't explicitly say, at least I don't think, is that if you have an arc, the degrees for that arc is going to be congruent to the angle. Only for central angles though. If you have a different angle somewhere else, it won't necessarily be the same. If you have a central angle, the arc will be the same degrees. Questions so far? All right, then we have adjacent arcs share a common point. So like down here, we have arc AL adjacent or next to arc LO, and they share a common point of 8. All right, so that would be adjacent arcs. And they also share a common point L. Then we have a postulate down here that you may want to highlight. Let me see if it's important. So the angle addition postulate states that you can add the arc angles to find the measure of the entire arc, if that makes sense. So if you want to find this measure, you can just add these two angles together, right? Same if you wanted to measure this outside of the circle, you would just add the interior angles because they should be congruent. You would have 89 plus 65. So if I needed to know the arc of AO, I would add them together and get 154. Any questions? All right, so 89 plus 65 is how I got the 154. All right, next page we have the arc addition postulate. So that one, the what it says is what I would highlight. So the measure of an arc created by two adjacent arcs may be found by adding the measures of the two adjacent arcs. So that's the same thing I drew on the page before. When I have central angles, the arc measure is congruent to the central angle measure. So notice that's congruent. If I wanted to find the measure of AO, I just add them together. Question. So the arc addition postulate. So let's apply this to an example. We have circle B shown below. The measure of angle CBD, so this right here, this angle, is 81 degrees. If the measure of CE is 42, kind of draw that in. The measure of CE is 42. What is ED? All right, so that's our unknown. And how'd you figure that out?
Because the angle to the central angle is going to be around the whole arc. So if you subtract 22,
All right, good, exactly. So this entire thing here, we know is going to be 81 degrees. If they just cut this in half, or not necessarily half, but they label from here to here 48, all I'm doing really is taking whatever the total measure is and subtracting the piece measure. All right, that's not like a formal formula, I'm just kind of writing it how I would understand it. So knowing that postulate helps me figure out what that missing side is. So I'm just taking the total, subtracting the piece, 81 minus 42 is 39. So the measure of ED equals 39 degrees. Does that make sense? All right, so really just making sure that we understand these postulates for when we get to a situation like that on the quiz. All right, so next page. We have, I don't know if this is a postulate or not, but we have two separate arcs are congruent only if the measures of their central angles are also congruent. All right, so like we said before, if it's a central angle, the arc measure is going to be the same degree. So it makes sense that if I have these two central angles for different arcs the same, then their arc measure should be the same, right? Kind of a given, but just in case. Now we have congruent arcs theorem. So anytime you see a page like this, the part that says what it says is usually the most important. So congruent arcs theorem, two arcs are congruent if the central angles that intersect them are also congruent. Okay. Two arcs are congruent if the central angles that intercept them are also congruent. So that's what we just said. Here's it illustrated again. So if you were making a proof or having to fill in a proof, you could say congruent arcs theorem as your justification for how you know this angle measured. Questions? Move right along. All right. So here's some practice. Some we'll do together, some I might just have you do on your own. So practice 1. Circle A is shown below. If the measure of angle CAB, so really the measure of angle A, is 60 degrees, what is the measure of CB? Is the 60 degrees right here, is this a central angle?
Yes.
Yes. So one of my postulates can help me figure out what that measure is. What's that measure?
60 degrees.
60 degrees. All right. So if it's a central angle, the angle measure will be equivalent to the arc. All right. The central angle. All right. Practice 2. So we have circle C shown below. Measure of FCB is 133. If the measure of FE is 69, what is the measure of EB? Right. And how did you figure that out?
Because your arc is going to be the same angle. So, 133 minus 69. Well, that's 60.
All right, exactly. So since this is my central angle, this entire thing equals 133. So my total measure is 133. They only gave us the measure of a piece of it to label. So to find the missing piece, 133 minus 69, that's how we get 64 degrees for ED. All right, questions, comments? 64 is for ED. All right, practice 3. So circle B is shown. We are told that EBD, the angle of that, so that this angle is congruent to angle CBF, so this angle. What's the value of X? So knowing that the central angles are congruent, what do we know about these arcs? Are they congruent, half of each other? Are they what? All right, good. They're going to be congruent because the angles are congruent. They told us the angles are congruent in the problem. So over here, they didn't give us exact measures, so they're going to make us solve for it. This is the measure of one of the arcs. And if it's congruent, that means it's equal to the other arc, which is measured as 3x plus 2. Anyone confused how or why we set it up that way? All right, and since they're equal to each other, there's only one variable to solve for. We can solve for x. So a little bit of algebra, I'll kind of help you out since you don't really focus on the algebra part as much. So I want to first move the x's to one side. I can move it either direction, just pick a direction. Usually I'll move the smaller x just so I don't have to deal with negative numbers. So how can I make this 3x cancel out? So to make it go away, subtracting 3x. So we want it to completely go away on one side. The only way to do that is to do 3x minus 3x. And then what you do on one side, do to the other side. So we did it on the right side so that we can get x's on one side. So we wanted to eliminate it there. On the left side, what's 4x minus 3x? 1x, this x. And then we have still the minus 7. Bring that down. Now how can I get the x by itself? How can I make this negative 7 equals 0?
You add 7.
Good. And then again, you have to do it to both sides. We got the x by itself on the left. On the right, what is 2 plus 7?
9.
So the value of x is 9. And it only asked for the value of x. It didn't say like what's the measure of ED. If it did, you would just plug that in, right? But it only asked for the value of x, so we can stop there. Questions? All right, now circle D shown. We have GDE equals 128 degrees. What is the measure of MHE? Or sorry, not MHE. GHE. So we're looking for this side. How can I figure that out?
360 minus 128.
Good, because 360 is
The full circumference of the circle.
the full like degree measure of a circle, right? So I just have to do 360, which if you didn't know would be the full circle, minus the piece measure, whatever you want to call it. All right, these aren't formal definitions. This is what I would use if I was you to solve these. All right, so we have 360 minus this piece that they did give us, even though they didn't explicitly say. What's that measure?
232 degrees.
So the green that I have here.
128.
Good. So subtracting that gives me what's in the red, which is what it's asking for. So that answer would be
232.
That sounds correct. And it is. All right, so the measure of GHE is 232 degrees. All right, also just a side note, because when you get to your practice for this, or maybe the next lesson, sometimes the pictures aren't drawn to scale. So even though it looks like maybe one side is bigger than the other, you know, just keep in mind the pictures aren't drawn to scale, just do like based on the definitions for solving. Questions? All right, so moving along, I know this is a lot, we're just gonna kind of keep going. Then let's talk about secant angles. So we kind of touched on that in the beginning, but they are a line that passes through a circle and intersects it at 2 points. So it goes through a circle, that's like the key part, and intersects it at 2 points. When two secants intersect, secant angles are created. So note, those aren't the same as central angles. All right, maybe let's say this one is 80 degrees, that doesn't make this 80 degrees. All right, that is not correct. So just keep that in mind if secant angles are labeled. Don't treat them like central angles. And there's some examples of central angles. We have the one here, or BAN, NAM, NAD, and DAB. Right, those are all secant angles. Questions so far? All right, I'll put them in different colors just so you don't think they're congruent. All right, now it says, how do you measure the vertical angles given the measure of the arcs? Let me see in my notes because I don't quite remember. All right, so I'm going to have you write down this definition. So for secant angles, so if you leave it in this slide, I think you'll be able to find it on your test. So the angle will equal half of arc 1 plus arc 2. All right, so write that down on this slide, top of page 6. That's how you can find the measure of the vertical angles given the measures of the arcs. Remember, vertical angles are like what's labeled here. They're angles that are across from each other when lines intersect, so they should be congruent. Okay, so to find the measure of the vertical angles given the measure of the arc. So arc 1 can be this one, so we'll put 79, plus arc 2, which can be the other one, so plus 31. What is 79 plus 31?
110.
110. And then half of that would be
55.
55. So it is labeled in the picture, but if it wasn't, then that's how you find it. All right, you take half the value of arc 1 plus arc 2.
Could we just put it in as 1/2 and then this is half your arcs?
Yeah, so you can enter it in the calculator, like all at one time, you can do this. And I would put the fraction in parentheses because fractions are kind of tricky in some calculators. But yeah, you can do it all at one time. That's what I do normally. Questions? So in calculator, you can do it all at once. All right, the next two are based on what we just talked about, this formula that's right here. So I'll have you guys try that. So bottom of page 6, it says practice 1, practice 2. You're using this formula. So if you don't have it written down, write it down. And answer the next two on your own. So for practice 1, I would start by writing the formula. So we have the angle equals 1/2 arc 1 plus arc 2. So this time it's asking for, so HK is 55, JI is 63. It's asking for what this missing angle measure is. So we're solving for the angle. So since we're solving for the angle, we'll just write that as angle. And plug in the arc 1 value. What would that be? Good. Find that right here. And the arc 2 value is 60. Good. And order doesn't really matter there, because that's FYI. Since the angle word there is already isolated, you can just enter this whole thing in your calculator. What did you get when you put that in your calculator? 55 I did not get 55. Let me double check. Are you looking at maybe the problem before this one? I got 59. So 1/2. That's good. All right, 1/2 parentheses 55 to 63. That makes this missing angle 59 degrees. All right, good. Any questions there? All right. Practice 2, we have circle H shown. The measure of J and K is 57 degrees. And the measure of LI is 50 degrees. What's the measure of J and K? Or unknown is what this measure is. So you can use the same formula. This time we're just solving for something different, which means we have to do a little more algebra. All right, so what's the angle measure?
53.5.
So the angle that they gave us is actually 57. Good. So 57 right here is what goes for angle. Equals 1/2. We do have one of the arcs measures. What's the arc measure? 50. And then arc 2 is what we don't have. So that's what we're solving for. That's why it still says arc 2. Now we're going to need to solve for arc 2. So we're going to have to isolate it. And to do that, undo what's being done. Start with what's farthest away from it. So instead of getting rid of that 50 first, which is next to it, I'm going to get rid of that 1/2. How do I get rid of 1/2? No, but not multiplying by 1/2. We're multiplying, but by 2. All right, multiply by the reciprocal to get fractions to cancel out. So multiplying by 2 on the left side, that's what we did on the right side, so now they cancel. And then on the left side, what's 2 times 57?
114.
Good. And then on the right side, this went away. The only thing I have left is what's in parentheses, so those can go away now, because there's nothing outside of parentheses anymore. And how can I get the 50 to go away that's near the arc 2? Good. All right, only way to get that to equal 0 would be to subtract. And then 114 minus 50 is, what is it, 64? Okay. So my arc 2 that was missing right here is 64 degrees. Questions about that? So a little more algebra that time. If that's something you struggle with, just use this as a model, take good notes. So when you get to that problem on your practice or quiz, you can just switch the numbers. Good question. All right. So now let's talk about inscribed angles. So those are important. They are angles in the interior of a circle where its vertex is a point on the circle. So see how, so vertex would be like right there, the point of your angle. where the two lines meet is your vertex. And on inscribed angles, it touches like an edge of the circle. So its vertex is a point on the circle. So that's an inscribed circle, an inscribed angle. When two secants intersect on a circle, the intersection creates an inscribed angle. So in this example, at least, well, that's another inscribed angle because the vertex is on a point that's on the circle. So that's my inscribed angle. Question? All right, then. You have the inscribed angle theorem. So highlight where it says the measure of an inscribed angle is equal to half the measure of its intersected part. Right, that's kind of like a formula if you want to write it down. So an inscribed angle equals half of the intersected arc. All right, so the measure of like this angle in here on this picture is going to be half of the arc. So since the arc is 94, that's what they did right here. They took half of it, which is 47. So that measure for L is 47. Question? So this is an important formula that is not like specifically set in your notes, so make sure you write it down. All right, next page. All right, next one. So in circle I shown below, we have the measure of LIK. So this measure is 96 degrees. What's the measure of LJK? So LJK is a inscribed angle. That formula is half the intercepted arc, which intercepted arc basically just means the arc that the angle looks directly at. All right, so there's my intercepted arc. Is there a way for me to figure out what that piece is, the intercepted arc?
96 because the angle is touching. It's not flat.
So that's not why, but you are correct that it is 96 degrees. It's because this is a central angle. And it's a rule that central angles will have the same degree measure for their arcs. Right? For inscribed angles, it's half of that. So my intercepted arc is 96. What's half of 96? Or 0.5? 48. All right, so that means my inscribed angle is 48. Questions? Sorry, I know this is kind of taking long, but bear with me. Questions? All right, so we'll keep going. We have the secant angle or the secant tangent intersection here. So the important part is this right here. When a secant and tangent intersect at the point of tangency, the angles created at that point of intersection are half the measurement of the arcs they intersect. All right, so here's where the tangent line is. Here's where the secant line is. These are the angles they create. And it's always going to be half of the measurements of the arcs that they intersect. So this one is all the way at the edge. If a full circle is 360, half of that, because it does say half, is how they get 180 for here. All right, so these add up to 180, that's half of 360, that's because it's a secant tangent intersection here. Questions? All right, and then just FYI, if you were breaking this up piece by piece, this angle, this piece of the arc is 160 degrees, this piece of the arc is 200 degrees. So that's why this over here is 80 degrees and this over here is 100, because it's half the arc. Questions? All right, the next one, I think I'll help you out, but then I'll have you do practice 2 on your own. So practice 1, we have line RQ is tangent to the circle. If the measure of angle PQR is 70 degrees, what is the measure of QP? All right, so yes. So let me backtrack before you get there. What's this arc measure? So it's not a central angle. It's a secant tangent intersection, right? Which says that the angle is half the arc. So if this is half of the arc, then what does the arc have to be? 140. So it's not 360 minus 70. It's 360 minus 140. Does that make sense? And that equals, hold on, measure of QP. So we're looking for this, is 220. Right, and that sounds accurate. I think in my notes I did it wrong, but this sounds accurate. What would the angle be? 110. Good. It doesn't ask for it, but it's asking about the arc. It would say angle if it was asking about the angle. But good that you know how to figure it out. Questions at all? All right. So try practice 2 right here. Just try it real quick for a minute. Line XV is tangent to circle W shown below. If the measure of angle with arc YXZ is 124. what is the measure of y t x? So the angle created by these two lines is 124, which by definition is half of this arc length, which is what it's asking for. It's asking for the measure of YTX. So if this is half of the arc, then what does the arc have to be? And you did that by multiplying the angle by 2, right? So that's how we're getting that. Because by definition, the angle is half of the arc for the secant tangent intersection. Questions about that? All right, we're gonna take a little break because we've kind of been talking for a whole hour. So, and I know we only have a little bit more to go, but we're gonna take a break. So we'll be back in 15 minutes. About material to a circle theorem. So if two secants, two tangents, or a secant and a tangent intersect outside a circle, so basically any two lines that intersect outside a circle, the measure of the created angle between them is 1/2. So let me put one letter for you. 1/2 the absolute value of the difference of the measures of their intersected arcs. So I guess it would be arc 1 minus arc 2. All right, those are absolute value symbols, not parentheses. That's going to be the measure of your exterior angle for the circle. So write that down. Star, highlight it, whatever you need to do. Otherwise, you just have to read this definition and come up with it from there. All right, but this measure right here, that exterior angle, is equal to half the absolute value of the arc measure. So the arc measure is what it looks at, that's what it means by intersected arc. Question so far? All right, so have that formula in there. I'll write it on the next page too. So practice 1 in circle P, shown below. The measure of TU is 25 degrees, that's already labeled. The measure of SQ is 79 degrees, already labeled. What is the measure of angle QRS? So we're asking about this angle, which is an exterior angle. All right, so first, like if I was on a test and it didn't tell me this is an exterior angle, I would look at it, go through my vocab words, figure out what kind of angle that is so that I use the right formula. All right, and that formula is that the exterior angle equals half the absolute value of arc 1 minus arc 2. Those are absolute value symbols. All right, question so far?
So it's like the same as secant and tangent type formula?
Yes, except for that this is an absolute value symbol. So if I take the difference of them, of these arcs, and I get a negative number, that number switches to positive. All right, so normally I always just do the bigger one minus the smaller one. to avoid any issues with negative numbers, but if you did it the opposite way, like 25 minus 79, then, they'll just become positive. Also, I think the other formula we looked at had a plus sign. This one has a minus sign. Yeah. All right, so plug in what you have. So the exterior angle is what we're solving for. My arc 1 is 79. Arc 2 is 25. Or you can have these reversed because the absolute value will make it positive anyway. What's 79 minus 25?
54.
54. What's the absolute value of 54? So remember, absolute value is how far away something is from 0.
So
54.
54.
All right, so I'm going to kind of drop those. It's now multiplication, because out here this was times the absolute value of 54, which is 54. What is half of 54?
27.
All right, so my exterior angle right here is 27 degrees. And we did that by solving, or by using this formula, which we got from the definition. Questions, comments? Does this make sense? All right, I'll have you do practice 2 on your own, but there is one little part that I'll help you set up. So if you're still writing this one, finish writing it. All right, practice 2. So we have circle Q shown below. The measure UR, so this way, is 168, which is already labeled. The measure of RS is already labeled, and that's 124. What is the measure of angle STU? All right, that is an exterior angle. It's outside the circle. So use that formula that we talked about. But the part that I wanted to help you with, I still haven't gotten to yet, so I am going to let you do this one. 1 second. Here's your formula. Is you need the values of the intersected arcs. So you need the values of the arcs that the angle looks at. So it gave us the arc measurement for RS, but does the angle look at RS? It does not. But we can use that value to figure out what this is, which is the intersected arc. How can I figure that out? Plug it into. So.
Oh, to get the what's highlighted in black,
Yes.
then you would just do 124 plus 168. Whatever that is, subtract it from 360.
Good. All right, so this whole circle, a full rotation would be 360. So to find what that other intersected arc is, you're going to subtract the parts that you do know. All right, which is what Shelby said, just in different terms. All right, she added them together first and subtracted it. I just put it like this in my calculator. All right, and then, so you do that, and what's the missing arc?
68.
68. So it's 68 and 168 that you're putting for your intersected arcs. Does that make sense? All right, now you can use a formula to solve. I'll give you about a minute. So plug in the two intercepted arcs. So the arcs that your angle is looking at, what arcs would those be?
168 and 60.
Good. And you can have these flopped. You could have done 68 minus 168 because the absolute value will fix that anyway, right? So what's 168 minus 68?
100.
The absolute value of 100 is what?
100.
Good, because that's how many spaces from 0 100 is away from. The absolute value is. And then what is half of 100?
50.
50. So if you got 50 on your first try, good job. All right, if you're just waiting for me to do it, make sure you're asking questions if you're getting stuck on these. Questions? Hi,
Do you have a Justine Howard?
I do.
Okay, she's going home, so she needs to come to the front office, please.
Okay, I guess my phone isn't working.
Nobody's phone's working, they changed everything out, so.
Oh, okay,
It's all like
thanks.
that. Thank you.
All right, next one. Practice 3. SU, it tells you is 126 degrees, and it wants to know the exterior angle measure, right? Doesn't say exterior angle, but you know that it is because it's on the outside of the circle. Now, do I have all the information to be able to just plug it into the formula?
No,
I am missing,
your SVU arc.
good, I'm missing this arc over here. So how can I figure out what that arc equals?
You get 360 and subtract 126.
Good. So it just so happens that it covers the whole circle. There's not like in the last example where part of the circle was missing. So it's just the 360 minus the 126, which makes this arc equal what?
234.
All right. So to find that other arc, just remember circles are 360 degrees and do some subtraction. Right, now we can plug it into our formula. And we have half of the absolute value of arc 1, which is 126. Or we could do the other way around, but I'll show you since I already wrote it. 126 minus 234. What is 126 minus 234?
108.
100. So you did 234 minus 126, which is good. That's what I do. I just wrote it backwards this time, but I'll just show you that it still works. So the way I have it on the board, I got a negative, which is fine, because what's the absolute value of negative 108?
Positive 108.
Positive 108. All right, negative 108 is 108 spaces away from 0. So that's the absolute value. Basically makes anything positive. And then half of 108 is
54.
good. Any questions? All right, so sorry that was kind of a long lesson. Only hard part, I think, is just figuring out what formula to use. So look at where the angles are located, then use whatever postulate theorem it is that matches that to figure out the missing sides. All right, you guys picked up a packet called the 9.01 practice. I don't know how long it'll take you. I'll set aside 15 minutes and we'll see how it goes from there. Assuming that you're all working hard on it. If you're not working hard on it, then it'll just be 15 minutes and then we'll move on. Sound good? All right, so we'll give you 15 minutes and we'll see where everyone's at in those 15 minutes.